Hi, my name is Jacqueline Brixey. I'm a PhD student at USC's Institute for Creative Technology, and my co-author is Dr. David Traum. And this describes our work on building a speech recognizer for the Choctaw language. So I'm sure we all know motivation for building a speech recognizer, but specific for the Choctaw language, it would be the very first speech recognizer for this language, and it could be a very useful tool for language learners to improve pronunciation and conversational skills. There's a lot of effort to revitalize the language. It would support documentation efforts, and it would also support the ideal of language technology for all. To tell you a bit about the Choctaw people, Choctaw is the name of the tribe, and it's also the name of the language spoken by that tribe. At last count, there are around 200,000 individuals who identify as being Choctaw, making it the third largest tribal group in the US by population. So this was a very famous chief. And then here you can see traditional regalia. Working on the speech recognizer is also personally motivated because I am Choctaw. And so pictured here is my grandmother, Ella. And to be an enrolled citizen in this nation, you have to have someone from your family had to be on something called the Dodge Roll, which was enrollment in the Choctaw Nation in the 1800s. So this document shows my great-grandfather, Noah Fraser, in 1899, enrolling in the Choctaw Nation. So Noah was her father. The Choctaw people originally inhabited the southeast part of the US, so Mississippi and Alabama. Today, there's a federally recognized tribe there called the Mississippi Band of Choctaw Indians. In the 1830s, there was the Indian Removal Act, so we were forcibly relocated to Oklahoma. And the tribal group is called the Choctaw Nation of Oklahoma, and I'm a member of that part of the tribe. There's also the Jinnah Band of Choctaw Indians in Louisiana, and then there's the Choctaw Clan in California, which is not federally recognized. It's mostly members of the Choctaw Nation of Oklahoma. It is estimated that there's around 10,000 fluent speakers, but this is a rather old number, and then quite a few fluent speakers passed away from COVID. Most of the fluent speakers were older, and of course the pandemic was particularly difficult for older individuals. The language is classified as being endangered by Ethnologue, and it belongs to the Muskogean language family. So some other languages in that family include Chickasaw, Alabama, and Muskogee. Choctaw is the largest language from that group, and none of the other languages have speech recognizers. Okay, so the language is pretty well documented. It was first documented in the 1800s by a missionary named Cyrus Byington. He gave us our first grammar, our first dictionary, and our first writing system, which is still largely the one used in Oklahoma today. There's been other grammars over the years and several other dictionaries, with the most recent one being being published in 2016 by the Choctaw Nation of Oklahoma. The Mississippi Band is currently working on a dictionary, so it should come out in the next couple of years. In the language, there's 15 consonants. There's not too much variety in how this is represented in the orthography. There's just a bit of differentiation with the cha, sha, and an aspirated H sound. That's kind of a the. There's also 9 vowels, so short, long, and nasalized. And this is where there's quite a bit of variation in how people write. There's been attempts at standardizing the orthography, but out in the wild, yeah, it's pretty wild. And then I can also mention that the language is subject, object, verb. For reference, English is subject, verb, object. And the language has fairly complex morphology, which we are not currently looking at in the speech recognizer, but it would be a very interesting avenue for future work. So to build our system, we also used Colby. We're using the Wall Street Journal recipe, and this is built using HMM, so hidden Markov models. Perhaps there are other recipes that might be better suited for Choctaw, but at this stage, we are using the Wall Street Journal recipe, and it's building a monophone and a triphone acoustic model. So now I'll talk about the particulars. So to build the language model, there's quite a bit of data that we could potentially use. So in some of my previous work, I built a corpus called Choctaw Corpus, and it contains a variety of text. So some things from dictionaries, some bilingual texts, both from Oklahoma and Mississippi. I don't have any examples from the Jenna Band of Choctaw Indians. And then there's a variety of genres, so letters, poetry, religious texts, and also some transcripts of audio. In Colby, you need to include a lexicon, so it's a dictionary model. Our lexicon contains 2,700 entries. So I am not a fluent speaker, I'm a learning speaker, but I needed proof of how words were pronounced to include in the lexicon. So to do that, I looked in the 2016 dictionary. That was the one by the Choctaw Nation of Oklahoma. And in that, every single word entry had a pronunciation guide, how the word was supposed to be pronounced. So that's the reason why this number is 2,700, even though we have lots of text. To build the acoustic model, we have quite a bit of data available to us. In Choctaw, there's also around 14 hours of audio and 2.5 hours of video of Choctaw examples. We also did novel data collection. So in 2019, just before the pandemic, we went to Oklahoma and recruited speakers of varying fluency, from absolute beginner, it was their first day in class, to first language fluent, and really everything in between. So we recruited 48 speakers, and we asked them to repeat aloud 200 prepared phrases. The phrases were selected to cover a range of sounds. It's shown in alphabetical order here. And then I have an example of the first line being spoken by a fluent speaker.
Choctaw okay, Chisnato.
Loud enough. So even though they had prepared phrases, some variation did occur. So people would say a different word or left out words. So not all of the repetitions that we collected are exactly the same across participants. While we were in Oklahoma, we also collected dialogues. We focused quite a bit on dialogue in my research group. So of course we wanted to get some dialogue examples. So here we recruited 15 unique participants in 8 conversations between 2 people. One of the fluent speakers did it twice. They were encouraged to talk about any topic of their choosing for 15 minutes. And what I have here is one example conversation. It's right at the start of the conversation, so they're just greeting each other. But English translations are in the brackets. And then we were quite interested in seeing speakers of differing fluency levels, because we wanted to see how would they handle parts where they didn't quite know how to say something in Choctaw. Would they resort to English, or how would they resolve those types of confusion? So there are a few examples of code switching. So anything that's in English is bold.
Halito,
Chimachokma.
Chokma, Chisnato.
Chokma Kili.
Chokma.
Magnitaga nota Katimi Jishnoa.
Akakano. Ishnoa. Walking? You walk? Let me see. Tuxley Lachin. Chokme.
So the system that we're currently working on is only using the repeated phrases, so from those 200. And we're currently training a fluent speaker only model. So that would be 12 of those 48 participants. And at the present moment, that fluent model is trained on a subset, so 6 of those 12 fluent speakers. So if the total duration of audio available to us from the corpus is around 14 hours, the dialogue collection that we did in Oklahoma, around 2 hours, the total phrase collection is 35 hours. One note about this, when we were recording, we just left the audio player running. So if speakers wanted to repeat or make changes, they had that opportunity. The audio recorder was also running for when they were listening to the phrases being said as examples. So the total duration needs quite a bit of cleaning. So the 6 of those 12 fluents after cleaning, we had 45 minutes for training and 15 minutes for testing. So as preliminary results we have from this subset of our fluent speakers, our monophone model best word error rate was 49%, and the triphone model's best word error rate is 61%. So lots of room for improvement, but it was really exciting, nevertheless, that we have a working system. I can't speculate as to why exactly the monophone model is performing better than the triphone model. This is very early stages, and it could very well change once we add more data. So I'll leave that kind of analysis to the future once we've done once we've added that data. But if we could take just a minute to have a peek under the hood of what kind of errors we are currently making, it might shed some light on how to improve the model. So the gold standard of what it was supposed to be said is here on the left, what the monophone model produced in the middle, and the triphone model here on the right. So the first example is quite interesting because it looks like it's more of a language model issue. So this first word and this last word are actually pronounced the same, but one is a declarative and one is to mark negation. So no, I did not go to the party. No, I did go to the party versus I did not go to the party. So this is actually not a problem really with the acoustic model, it needs more language model data to understand. Also with this error on the triphone model, this is a subject marker, which is the exact same as this subject marker. The only difference is this one occurs after a word that ends in a vowel. So just a bit more examples and maybe we wouldn't have these types of errors. In the second example, the triphone model was perfectly correct. The monophone model made one error and said water instead of chicken. In the third example, the monophone model was perfectly correct, while the triphone model had a number of errors. The fourth, they both kind of went off the rails. And then in the fifth and the sixth examples, they were both able to recognize specific words such as hochapo, which is to say hungry, or holiso, which means book, but quite a few errors otherwise. So to discuss those results, this looks very promising for a small data set, and I think it could be very encouraging for other American Indigenous languages that don't have speech recognizers but are considering it and are curious to know how much data they would really need. I've also been speaking with the Mississippi Band of Choctaw Indians about the speech recognizer, and as I mentioned, they are working on a dictionary right now, and they think having a speech recognizer would be very useful for some of their fluent speakers to be able to access the dictionary. So many fluent speakers, of course, learned at home, but did not go to school and learn Choctaw, so they may not know how to read or write in the language. So it does make it difficult to access a text resource if you don't read that language. So for the future work, obviously we want to continue implementing what we currently have. We'd also like to include more dialogue, include the dialogue data and the data from the corpus that's available to us. We'd like to consider that complex morphology that Choctaw has and how to deal with the spelling variation. And we'd also like to consider, maybe for future work, to have a speech recognizer that also recognizes learning speakers, which is truly the largest population of Choctaw speakers at this time. So for us to be able to use any of these really great applications like word lookup or even speaking with a dialogue system, then the speech recognizer would need training examples of how we sound when we speak Choctaw. And now I'd be happy to answer any questions about the system or even for the process that we went through to record community members, since Choctaw Nation has its very own IRB, so that makes it kind of unique.
Very interesting. Thank you very much, Jacqueline. That was very cool. Right, we do have some time for questions. Alan, did you have a question there?
Yes, I do. Yes, I do. Thanks. That's an excellent presentation. Actually, I noticed for all three papers in this that we're addressing things in Indian subcontinent, American Indigenous languages, and later African Indigenous languages. I think this is cool. I appreciate all of the problems they are in collecting data, in finding people to actually collect the data, and given that it's often older people who speak these languages fluently, and it's often joked that most of the indigenous languages are all being collected from 80-year-old women because they're the only people who are left who speak the language.
Yeah, it definitely skewed more towards having female speakers being recorded.
And that's okay at some level, but there could be differences in the language. Overall, which is a comment on the previous one as well, for speech recognition, you can build dialogue systems with a 40 or 50% word error rate system, and it's just fine. I mean, it's not fine, but it will work. Okay, so
Very encouraging.
it's sort of okay to be that level of, yes, it's not good enough for transcription, and it might not be good enough for learners, but it is good enough to get information out often. The thing I wanted to recommend is, given the complex morphology and that most Native American languages are these very rich morphologies, polysemitic. I'm not sure if Choctaw is that or not, but looking at some form of automatic word segmentation, BPE, byte pair encoding, might be a really good way to find automatically smaller words that might give you a better entropy in your language model, and just make it easier to give a better result with a smaller amount of data.
That's a really great idea. Yeah, so there is quite a bit of like morphology, but it's not, as complex as
Okay.
other languages. Yeah, and then Oklahoma Choctaw is a bit different as well, because we've adopted this system of spacing out time. So there's a bit, it's not as inflectional as some of the other languages.
Oh, right. Okay. Well, that happens in dialects as well. So yeah, that's interesting. And the fact that you really like to share the acoustic data between it all, because that's sort of the hardest to get, but that means that the language model data may require some interesting normalization. Yeah. Are you intending to collect more data?
That would be wonderful. I'm also working on my dissertation, so that's
Okay.
first task here. But yeah, since the Mississippi band's been very, very interested, then that would probably be the next place for data collection.
And it's also interesting that you have a community who's interested in doing it. That was my second question. Are there other questions? Second question was, how do the native speakers feel about this technology? Do they think that it's just a waste of time to be able to talk to Siri, or do they see it as something that makes their language, more 21st century?
I would say that there's a good spread. Of course, some people are very reluctant. We don't want AI touching our language, and then there are other people who love tech, and they really want to see these tools for our language. So I try to listen to the excited ones, but yeah, of course, I want to hear from other people as well. What concerns do they have? What can I do to mitigate some of those concerns?
All right, so we are running out of time, but Judith, if you can keep it short.
Yeah, very quickly. I was just wondering whether you created any grapheme to phoneme rules to help cover the out of vocabulary words. It seems like you have enough pronunciation dictionary entries to be able to abstract away from that and create some rules to cover other words.
I hadn't done that at this particular stage, since I was just working with the repeated phrases, so they didn't differ too far off of what was supposed to be said, but there was some variation. So yeah, I think that might be for future work as we continue to develop it.
On side.
Mhm.
All right, so Jacqueline, if you could stop your